Okay, just a couple last things to wrap up this projectile motion problem. So we are going to see how well fminbnd did in finding the steep and shallow angles. So as we talked about before, fminbnd is overloaded to give two outputs, right? The local minimizer and then the function evaluated at that local minimizer value. Okay, so we're going to recall our functions and ask for the second output. So let's put a comment here that says, how good did fminbnd do? And instead of just asking for steep angle, I'm going to ask for steep angle and then the function squared distance discrep evaluated at steep angle, right? So let's call that steep SDD. So squared SDD is for squared distance discrepancy. Okay, and then let's grab this line of code to get the shallow angle. But in addition to the shallow angle, we'll also ask for shallow SDD. Okay, and now keep in mind that we're finding a minimum, right, which could be any value as long as it was the lowest value that the function produced. But in our particular example, the minimum is when x target and x land are the same, and so it actually should be pretty close to 0. Okay, so we're going to know if fminbnd did a good job if steep SDD and shallow SDD are pretty much 0. But again, just remember that that's not always the case with fminbnd. It might just be how small is it, or depending on what the function is, right, is going to depend on how you're going to know if it did a good job. Okay, so let's go ahead and run this and see what those SDD values are. Okay, so steep SDD is 1 times 10 to the minus 14. Same for shallow STD. Our simple problem is symmetric, right, so that kind of makes sense. And now that we have those, we could go ahead and add a couple data points to our plot for fun. Okay, so let's do hold on and let's plot. So shallow angle, shallow SDD, and let's do black x's this time for something different. Okay, and then we can plot steep angle, steep SDD. We'll do black x's here too. Okay, so let's run this section, and there on our plot you can see we've added those x's. Now just for fun, we could have done that in one line of code, plotting both of those x's. Alright, so we could have made a vector of the angles. So in square brackets, I would include shallow angle and steep angle. So that's the first input to the plot function, and then I could have made a vector of the SDD values. So shallow SDD, steep SDD. Okay, square brackets making that a vector, and then said I wanted, well, let's do something different for fun. So let's do blue circles. Okay, and let's run that section, and now we've got blue circles marking the good angles to hit the target. Alright, and that's it for this part of the lecture 17.